All right, welcome back, everybody. This is Chris of the Ancient Scholar. Hope you all are doing well. All right, so this is going to be video 2 in my series of videos that aim to talk about the basic physiology and the basic terminology of mechanical ventilation. And again, this is to build some intuition about what is going on with a mechanical ventilator and how to understand all of the terms, and then develop some intuition for how to fit that into a specific type of ventilator, in this case, the Hamilton T1. All right, so the next thing I want to talk about is the breathing cycle. So under normal physiological circumstances, the breathing cycle really consists of two phases: the inspiratory phase and the expiratory, or the exhalation phase, right? And the cycle, right, what actually is responsible for the inhaling, exhaling, and the overall cycle, and how long you inhale, how long you exhale, is primarily a result of the overall information processing that occurs in the respiratory centers, and then the output from those centers that then cause the muscles of breathing to contract, and then you inhale actively through negative pressure, and then the muscles relax, and you passively exhale, mainly due to the elastic forces in and around the pulmonary system. However, when it comes to mechanical ventilation, you now have a machine that is doing this process, right? There have been some attempts to try to integrate technology into the person, to try to take the neurological inputs and outputs and use them to develop some breathing pattern. And there have been, attempts to do that with probes and things like that, but nothing super fruitful. And so essentially what we're doing when we initiate and make changes to mechanical ventilation is the mechanical ventilator is what is setting that overall, the overall inspiration and expiration. And in some cases, it is also allowing the patient to do some of their own spontaneous activities. So sometimes it's the ventilator is fully controlling the show. Sometimes it's a mixture of the patient and the ventilator, and other times the patient is primarily running the show. But in all three cases, there is an artificial airway in place, and when the ventilator is actually providing the support, it is producing positive pressure. So that gives rise to four major phases of a mechanical ventilatory breath. So mechanical breath consists of four major phases. And the terminology I'm going to present here is very important for understanding additional concepts that we're going to talk about in subsequent videos. So the first phase is what we call the trigger phase. So whenever you see the term trigger in reference to mechanical ventilation, trigger means what starts the inspiration. What variable is that ventilator using to determine the start of inspiration? Is it a time, right? Is it inspiration is purely based on some sort of time setting? Is it based on a pressure? Is it based on some flow of air being sensed, right? Whatever the case, that is what we call the trigger. So when we're setting up your ventilator, you need to think about trigger, right? Whatever the ventilator is using as a trigger, that trigger means to start the inspiratory cycle. Okay? So whatever triggers the ventilator is what the ventilator is using to determine when to start or initiate inspiration. All right? And then once the ventilator is triggered, you will move into what's called the inspiratory phase. The inspiratory phase is the phase of ventilation where the mechanical ventilator is delivering positive pressure into the patient's pulmonary system. All right? Now, within the inspiratory phase, mechanical ventilators have a variety of variables. There are what we call variables that we can essentially set, right? We can use the ventilator. There are certain variables the ventilator can control during the inspiratory phase. And there are two major categories of variables. There are what we call control variables. Control variables are parameters that the ventilator uses as a feedback to control inspiration. And essentially, a control variable is what the ventilator uses to determine when the inspiratory phase needs to stop and the expiratory phase needs to begin. And the term for stopping inspiration and beginning expiration or exhalation is cycle. All right, so a control variable is used to cycle the ventilator from inspiration to expiration or exhalation. All right, and I'm going to talk about these variables in more detail. This is just a basic foundation. So you have certain variables that you can control. And the two major variables that we can control with modern ventilators are pressure and volume. Typically, you can only control one variable at a time. You have to choose. Are you going to control pressure or are you going to control volume? And so when you hear the term volume-controlled ventilation, for example, that is a paradigm of mechanical ventilation where volume, a certain volume, is being used to terminate the inspiratory phase and to cycle the patient into exhalation. So if you set a volume of, say, 500 milliliters, and the ventilator will deliver that 500 milliliters, and then once the 500 milliliters has been delivered, then that will terminate inspiration and the ventilator will cycle into exhalation. So trigger is what we use to initiate inhalation, and cycle is what we use to initiate exhalation. And the control variables are the primary variables that the ventilator uses to determine how I cycle out of inspiration. And these are sometimes called control, right? Like pressure control ventilation uses pressure, volume control ventilation uses volume, all right? In addition to that, you have what are called limit variables, okay? Limit variables or targeted variables. And these are very different from control variables. So a limit variable or a target variable are constraints that we can set on the parameters of a breath. We can set certain constraints or certain limitations, if you will, right? During an inspiration, we can tell the ventilator what is the maximum value of something allowed. It may be pressure, it may be volume, maybe flow, something like that, right? Now, this is the important part here. The limit variables do not terminate the breath, okay? So if you are limiting pressure, say, you're telling the ventilator, I want you to prevent the patient's airways from experiencing a certain pressure, but you'll prevent that, but inspiration will not stop. You'll just get to that pressure and you will not continue increasing flow, volume, or whatever, right? But the patient will still remain in the inspiratory phase of the respiratory cycle. They will not cycle out of inspiration. So limit variables are going to limit something like volume or pressure, but they will not, once the patient meets the certain limit, okay, they will not cycle out of inspiration. All right, so limit variables limit the maximum value of something, but they do not terminate the breath. So they are not control variables. So control variables, that's what you are using to terminate the breath. Limit variables are constraints that you're placing on the parameters of a breath during inspiration. All right? So you could have volume control ventilation where you are using volume as your control variable, but you might have a pressure limit where you say, I want you to target this tidal volume, but I don't want you to exceed this airway pressure, all right? So volume is the control variable that is used to cycle out of inspiration, whereas pressure is one of the variables that we're limiting. And limit variables, you can limit more than one thing at a time, whereas control variables, you generally only have the ability to use one variable at a time as a control variable. Typically, in modern mechanical ventilators, it's either going to be pressure or volume controlled ventilation. And that's where the term pressure controlled ventilation and volume controlled ventilation come from. Those terms come from the control variable that the ventilator is using to terminate inspiration and to cycle into expiration. And then on top of that, right, either that volume or pressure that you're controlling, that you're using to cycle, you may have some limiting variables that you're putting in as well. All right? So that is the inspiratory phase. And then the cycle phase, again, is whatever control variable is met to start exhalation. And so you cycle out of inspiration and then you transition into exhalation. And the last thing that I want to mention about exhalation is almost entirely a passive process when it comes to mechanical ventilation. Just like normal breathing, where it is essentially a passive process, it is also a passive process when it comes to mechanical ventilation, which means that we, even if we put somebody on a ventilator, do not have a whole lot of control over how someone exhales. Even with an artificial airway and even on mechanical ventilation, we largely are not able to control how somebody exhales. And I'm going to talk a little bit about respiratory mechanics and the equation of motion of the respiratory system. But exhalation is primarily going to be the result of the elastic forces and how efficiently air can flow through airways and out of the patient. And a mechanical ventilator really can't do much about that. So that is an important consideration to think about. All right, everybody, I'm going to go ahead and wrap things up here. Hopefully you enjoyed this video, and we'll see you in the next one.